Okay, section 2.6. We're going to talk about how to solve problems and a technique called dimensional analysis. But first, we need to review a little bit of math. So we need to remember that anything divided by itself is 1. This is a really important principle. So 6 divided by 6 is equal to 1. Centimeters divided by centimeters is equal to 1. Units act a lot like variables in algebra. So in algebra, we use things like x and y, right? So x divided by x equals what? 1. Anything divided by itself is 1. Doesn't matter what it is. So units, numbers, anything. Another important idea is that multiplying anything by 1 doesn't change it. So if we take 17 and we multiply by 6 over 6, that kind of looks complicated, doesn't it? Until we realize, oh, 6 over 6 is 1. 17 times 1, that's just 17. We don't need a calculator or anything. 23 times centimeters over centimeters is just 23, because centimeters over centimeters equals 1. Okay? Important math principles. So what we're going to learn how to do is solve problems like this. You bought 5 dozen eggs at Costco. How many eggs did you buy? Now, I think a lot of you can figure that out in your head, right? How many would that be? 60. How'd you do that? 5 times 12, right? Why wasn't it 5 divided by 12? Because you understand what's going on, right? You realize that 5 divided by 12 would be less than 1, and obviously you have more than one egg, right? So some of these things we know how to do without really thinking about them, because they are things that we're familiar with. If you can do a problem like that in your head, you can learn how to do other sorts of problems that we're going to need to do in chemistry. But you can't put up a mental block and say, oh, that's too hard, I can't do it. Because then that becomes a self-fulfilling prophecy, and you're right, you can't do it because you're not willing to try. We can do this, okay? I know it may be challenging and scary for some of you, but we can do this. We're going to learn a technique called dimensional analysis where the units are going to tell us what to do. And we're going to initially look at it with more familiar units like dozens and eggs and feet and inches and things. And some of you will say, yeah, but I can solve those problems without doing all that writing out stuff. I'm trying to teach you the process because you're going to need it later in the class. Later we're going to be converting grams of hydrogen into moles of hydrogen and moles of water and into grams of water. And that's not one that you're going to be able to just reason out in your head. But if you learn the process, it's not going to be hard. So bear with me and try to grasp this process. I know that some of these early problems are things that you've learned how to do different ways. I want you to give my way a try. So I'm going to try to keep with what your book, the terms that your book uses. And your book talks about an equivalence statement. An equivalence statement is just saying that two things are equal. And here are examples. 1 dozen eggs is equal to 12 eggs. Those two things are the same, right? You used that equivalence statement in your mind when you solved the Costco egg problem. Another example is that 1 foot equals 12 inches. A foot is the same as 12 inches. We're just calling that length by a different name. That's all we're doing when we're converting units. We're not changing the length or the mass or anything. We're just calling it by a different unit. A gallon is the same as 4 quarts. These are things that are equal. From those equivalent statements, and those are the sorts of things that when you're trying to do a unit conversion problem, you'll look in the book and you'll find a table and it'll give you equivalent statements like that. From those equivalent statements, we can make a conversion factor. From each equivalent statement, you can make 2 conversion factors. So here are some examples. Where did these come from? Well, they came from the equivalent statement. So let's just look at feet and inches because that's shorter to write than the 12 eggs. So 1 foot equals 12 inches, right? So that's fine. How do we get these ratios or these fractions out of that? Well, here we have something that's equal. It's a little bit like two children sitting on a teeter-totter. Or these guys are standing because I can't draw stick people sitting very well. Oh, there, that guy's sitting over it. Okay. Two children on the teeter-totter, and it's balanced, right? If I give this child an 8-pound bowling ball, what's going to happen? That side's going to go down, right? But what if I give this child an 8-pound bowling ball also? Then it's balanced, and it stays the same. That's what happens when we do the same thing to both sides of a mathematical equation. A foot equals 12 inches. If I divide both sides by 1 foot, is it still equal? I gave each child an 8-pound bowling ball. I did the same thing to both sides of the equal sign. It's still equal. Okay, well, let's look at this. What did I make here? What is 1 foot over 1 foot? That equals 1. Anything divided by itself equals 1. So that means that 12 inches over 1 foot equals 1. Any questions? All of these equivalent statements are mathematically equal to 1. Because when we look at them, 1 dozen eggs, is that the same as 12 eggs? Yeah, those are equal. So when they're written out this way, they look different, but they represent the same thing. Anything divided by itself is 1. Question?
How about with things more than 2?
Yes. Well, you mean more than 2 units?
More than 2 variables? Or...
We're always going to do just 2 at a time. Yeah. But we'll sometimes string them together. So any of those equivalent statements, we can write, you just pick one and put it on top and the other on the bottom, or turn it upside down. You can turn it upside down because it's equal to 1, and what's 1 over 1? 1. It's still 1. So we can flip them upside down. Invert them is the fancier name. So another way to think about this, if we look at the 12 feet, 1 foot, I wrote the right thing at least. 1 foot equals 12 inches. If you imagine that this is the fraction line, okay, and you can tip it this way and end up with 12 inches over 1 foot, or you can tip it this way and end up with 1 foot over 12 inches. So you're taking that equivalent statement and you're twisting it. You can either rotate to the right or you could rotate to the left. That's just another way, a less mathematical way of thinking about it. We need to be able to look at equivalent statements and make these conversion factors. Does anybody have any questions? So what we're going to do is we're going to take the unit that we're given and we're going to multiply it by a conversion factor to get the unit that we want. So just going back to the Costco egg problem, 5 dozen eggs. We know we have 5 dozen eggs, and we want to know, well, how many eggs is that? The number of eggs. Well, what's the relationship between a dozen and the number of eggs? 1 dozen equals 12 eggs, right? 1 dozen equals 12 eggs. So we can write 2 conversion factors from that. 1 dozen over 12 eggs, or we can upside down it, 12 eggs over 1 dozen. We cannot say that 1 egg equals 12 dozen, right? Because that's ridiculous. So those are our 2 possibilities. The number that we have 5 dozen, and we want to multiply this by a conversion factor. And over here we want to end up with number of eggs. So which one of these conversion factors should we use? We want the dozen to go away. If we use this first one, we're going to end up with dozen times dozen divided by number of eggs. We're going to have a mess, right? If we use this one, we're going to be good. We've got 1 dozen on the bottom, and we've got 12 eggs on the top. This is dozen divided by dozen. What's a dozen divided by a dozen? It's 1. We say those cancel out. Anytime you have something divided by itself, they cancel out because they're 1. And then when you multiply by 1, it doesn't change anything. So poof, those units disappear. We're left with the unit eggs, number of eggs. So we get all the units to work out. Then we do the math. We've got 5 times 12 divided by 1, and that's how you got 60 eggs when you did it in your head. Any questions? So some of you like a list of instructions, almost a checklist. So here's your list. This is the steps for doing this, and we're going to be doing a bunch of examples also. So the first step is when we're converting from one unit to another, we're going to use an equivalent statement that relates the 2 units. In that example, we had dozen and number of eggs. We don't want to use the relationship between feet and inches or a mile and yards because that doesn't help us. It's the 2 units that we're dealing with. Choose the appropriate conversion factor that will make the unwanted units cancel out. From the equivalent statement, you can make 2 different conversion factors. You choose the one that's going to make the units work out. That's how the units tell us that we need to multiply by 12 instead of dividing by 12. Then we do the multiplication. And then always check the number of significant figures at the end. Okay? I taught you about significant figures, and now we're just going to practice using them for the rest of the semester. And then always ask yourself, does my answer make sense? And sometimes you can see obvious, yeah, that makes sense, or no, that's ridiculous. Other times you can look at that and you're like, I don't know. But at least try, okay? And the bigger, smaller thing, what does that mean? The bigger unit should have the smaller number. The smaller unit should have the bigger number if you set it up correctly. So we'll talk about these steps as we do some examples. So here's an example. A golfer putted a golf ball 6.8 feet across a green. How many inches does this represent? So this is what they call a word problem. They called them story problems when I was a kid. I don't know if that's because it was so long ago or because I grew up in the Midwest. I don't know, but I called them story problems. I'm trying to learn to call them word problems. This is a word problem. For many people, getting from the word problem to a mathematical equation is the problem. It's not that you don't understand the math, it's just interpreting this. And it doesn't mean you're stupid, it just means your brain works differently. There's people who get story problems, and there's people who don't. And it has nothing to do with intelligence. So I'm going to try to help you learn how to deal with these story problems. So always read through the question all the way through. And then the numbers are going to be important. So let's identify the numbers here. Well, this question is nice. It only has one number, 6.8 feet. So that's going to be important. So I'm circling it here. If you're doing this out of the book or something, then you're going to want to write that down. 6.8 feet. Okay, that's going to be important. No other numbers. And then, what are we trying to find out? And this usually comes in a sentence with a question mark. How many inches? How many inches? That's what our question is. So we want to identify what unit we're starting with and what unit we're trying to get to. So they gave us feet, and they're asking us to find inches. Do we know a relationship between feet and inches? Yeah. 12 inches equals 1 foot. What do you do if you don't know the relationship? Look it up. When you're doing homework, you've got the world at your fingertips if you have access to a computer, or you've got your textbook, and most of the conversion factors you're going to need will be in your textbook. I think there's a table in the back cover that's pretty useful. On an exam, it will either be something that I've asked you to memorize, or I'll give it to you somewhere on the exam. But there's our relationship, and we're going to make an equivalence. That is the equivalence statement. We're going to make a conversion factor. What we're going to have here is we're going to have our 6.8 feet, and we're going to multiply this by a conversion factor, and we want to end up with inches, right? So we can make two different conversion factors from that equivalence statement. We can put feet on the bottom, or we can put feet on the top. But let's look at what we're doing here. Here we're starting out with feet. What do we want to put on the bottom? We want to put feet on the bottom because we want those to cancel out. So that means we're going to have to put the other unit on the top. Now we can't just ignore the numbers because the an inch doesn't equal a foot, does it? So we need to bring these numbers along. So this 12 inches has to stay together. So that's 12 inches. And over here we've got 1 foot. That has to stay together. So we're going to take 6.8 feet and multiply it by this fraction, 12 inches over 1 foot. And we see that what happens with the units is the feet cancel out, which is what we wanted to happen. And we can multiply by this fraction because it is numerically equal to 1. 12 inches is equal to 1 foot. This guy right here equals 1. So all we're doing is we're changing what we're calling this length. We're not actually changing the length. So then you use your calculator. Come on, calculator. There you are. 6.8, and we're going to multiply by any numbers that are in the numerator. Any numbers that are in the numerator. That's kind of hard to say this morning. The top. We're going to multiply by the top. We're going to divide by the bottom. So 6.8 times 12 divided by 1. Now, obviously, you don't have to divide by 1, but if you want to, you go right ahead. Calculator says 81.6. So we should check our significant figures. This conversion factor is exact. There's exactly 12 inches in exactly 1 foot. And so we will look at the number that we started with. How many significant figures does that have? It has 2. So then our answer should have 2 significant figures. So we're going to say this is 82 inches. And that's our answer. We also have to ask ourselves, does the answer make sense? Which unit is larger, a foot or an inch? A foot is a larger unit, right? So here we have the larger unit, and 6.8 is the smaller number. Over here, we have the larger number, 82, and the smaller unit. The thing that goes wrong most often is that you get this upside down for one reason or another. And then your number ends up getting smaller instead of bigger, or vice versa. And so the bigger, smaller rule to check your answer will usually catch it if you did that. Just sort of a shortcut for significant figures works most of the time. Most of the time, the number of significant figures in the number that you're starting with is going to end up being the one that limits the number of significant figures in your answer. And so if significant figures are a problem for you, especially all those rules about the multiplying and the adding stuff, a good shortcut is to just say, oh, well, I started with 2, I'm going to end up with 2 significant figures. Okay, that works most of the time. Any questions about this problem? This is how I want you to set up your work, this guy right here. I want you to be able to show your work like that, with units behind every number, showing how the units cross out, writing down what your calculator says, and then rounding appropriately. And the reason is not because you couldn't do this one just by punching some numbers in your calculator and writing down the answer, but because you need to learn this technique, because later we're going to have 3 conversion factors in a row, and they're going to be units you're not familiar with, and you're going to be in a world of hurt if you don't learn how to do it this way. Okay? I've taught this class more times than I care to admit. And this technique works. In fact, dimensional analysis, I learned this as a junior in high school. And I'd say it's probably the most useful thing I learned in my entire high school career. Dimensional analysis. How to deal with the units and manipulate the units. You can do just amazing things. So here's another example. An iron sample has a mass of 4.50 pounds. What is the mass of this sample in grams? And just to save us some time, I've put up a couple of equivalent statements there. A kilogram is 2.2046 pounds, and a kilogram equals 1,000 grams. So we read the problem. Let's find the numbers. Okay, there's only one number, right? 4.50 pounds. So that's going to be important. That's got to be where we're starting, because it's the only number given. What are we trying to do? What unit are we trying to convert this to? Grams. You have to know where you're starting, and you have to know where you're going. That's why when you go to a strange place and you look at the map that's on the, like at the mall or something, it says you are here. Because if you don't know where you are, the map doesn't help. Okay, so now what we have to do is we have to decide, well, how are we going to get from pounds to grams? So I'm going to start out with pounds, and I want to end up with grams. And this is a little bit, like Dora the Explorer. And she's like, well, here I am I'm blanking. Here I am at the Rusty Bridge, and I need to get to the Snowy Mountains. And I don't know how to get there. And so she asks the map for help, right? And the map says, well, you're at the Rusty Bridge. Next you have to go to the Scary Forest, and then you can get to the Snowy Mountains, right? And then they all chant, Rusty Bridge, Scary Forest, Snowy Mountains. They chant it like 3 times, right? What we're going to do is we're kind of think about that in our heads. We're going to figure out, where am I trying to go, how am I going to get there, and then we're going to write it down. We're not going to draw a fancy map like Dora has. We're just going to list units with arrows in between. Do we know the relationship between pounds and grams? Off the top of our heads? No. We could look it up, but let's pretend that this is all we've got. So can we convert directly from pounds to grams? No, we don't have the equivalence statement. What are we going to do? Well, what do we have here? We have this telling us that this many pounds is equal to a kilogram. Could we convert from pounds to kilograms using this? We could. So we could go from pounds to kilograms. Oh, and look, they gave us that. Could we go from kilograms to grams? Yeah, we could. There's more than one way to do these problems, generally speaking. If you were able to go look up and see that a pound, I think it's like 453 point something grams, you could use that and do it in one step. We're just going to do this in 2. So this relationship is what we're going to use for that guy, and this relationship is what we're going to use for that second step. And that was a straight line. So what we're going to do is we're going to start out, we're going to write down what we were given, 4.50 pounds. And we're going to look at this map. This is what I call the map. We're going to look at the map and we're going to say, what is it telling us to do? Pounds, kilograms, grams. There are two arrows. Each arrow represents a conversion. Each arrow represents a conversion factor that we need. So you get that map, and that tells you I've got two arrows, I need two fractions. Then the map tells you what to put on the top. Pounds to kilograms to grams. Here we've got pounds. So on the next line I'm going to write kilograms, and then over here I'm going to write grams. So it's like Dora chanting. Pounds, kilograms, grams. Pounds, kilograms, grams. Isn't that nice? We can do that, right? Once you get the map, remember the map tells you where to go when you don't know where to go. Once you get the map, the rest of it is just following a pattern. So for every arrow, you have a conversion factor, a fraction. These units are the ones that go on the top. Now, we need to get rid of pounds. How do we get rid of pounds? We want to divide by it. So we're going to put pounds in the bottom, and that would mean that pounds over pounds equals 1, cancels out. To get rid of kilograms, we put the kilograms over here. Kilograms over kilograms equals 1, they cancel out. So we've messed with the units and gotten them to cancel out. We can't stop there because we need some numbers, because a kilogram is not equal to a pound. But we made this path based on relationships that we knew. And now we use these numbers and put in here. The number 1 is in front of kilogram. So I'm going to put 1 in front of kilogram in my conversion factor. What's in front of pounds? 2.2046. 2.2046. I didn't leave enough room. It's okay. What's in front of gram in this guy? 1,000. So I'm going to put 1,000 here. And what's in front of kilogram? 1. I'm going to put the 1 in front of the kilogram. Really important to keep the number and its unit together. You can't just switch them because you'd rather multiply. It doesn't work that way. Any questions about how I got that set up? Now we're ready to go. We get out the calculator. And what I recommend doing is just start at the left and go across, multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. So on our calculators, what we're going to do is we're going to have 4.50 times 1 divided by 2.2046 times 1,000 divided by 1 equals, and then I'm going to write down what my calculator shows me, 2041.18661. And what unit was left? The only one that didn't cancel out was gram. There's an answer. It's not the best answer yet, but it's an answer. We should round this to take into account the number of significant figures that we have in our beginning number and in our conversion factors. How many significant figures does 4.50 have? So we know it has at least 2, the 4 and the 5, and that 0 is one of those confusing guys. That's a trailing 0, and there's a decimal point in the number. So that means that the 0 counts. So that has 3 significant figures. How about this guy? That's more than 3, right? That's 5. This, a relationship between grams and kilograms, is an exact conversion. This is a metric-metric relationship. This is an English metric. Most English metric relationships are not exact. So what we're doing is we're comparing 4 sig figs versus 5. I said 4, didn't I? Gosh, 3. There's only 3 digits there. 3 sig figs versus 5. So 3 is how many we should keep. We come over here, we want to keep 1, 2, 3. We need to be careful. We can't round this off to 204. It's 2041. What's the name of this place? That's the tens place, right? We've got the ones place, the tens place, the hundreds place, the thousands place. If you were rounding off and that last digit you're keeping is in the tens place or higher, you need to be careful. And I really recommend putting this number in scientific notation first and then rounding it off. So 204,118,661 times 10 to the third grams. Now, 1, 2, 3 significant figures. We don't have to worry that we're changing the value of the number. Bless you. Could you write 2040 grams? You could. It's not the best. Okay, so we're out of time. Work on the homework, but before you do that, read the section of the textbook, look at the examples they've worked out, and then work the ones that they've set up for you. I think it even has a place where you can cover it up with paper and try to do the next step and then check, oh, am I doing it right? And it'll lead you through these. So work on that, and I'll see you on Friday.